Now we were dealing with the equivalent circuits. Now this new version of an equivalent circuits, if you look at this two circuits here, this blue one is the equivalent to that black one box, black colored box. If you say it in words, an independent current source in parallel with a resistor can be replaced or is equivalent to an independent voltage source in serial with a resistor with the same resistor value. This is called source transformation. So, let me write it here. Source transformation. Although it says source transformation, this is an equivalent circuit. Example. So in order to arrange that, this is, let's call it, at the beginning we call this Vs. So we are going to find out what Vs value should be in order to have that black circuit to that blue circuit. So we're going to calculate it, at the end we're going to find that. At the beginning we assume that this is Vs. So how we are going to say that this is equivalent? So we are going to say that if this element current and voltage on the left hand side circuit is the same as the right hand side circuit VL and IL values, then we are going to say that blue is equivalent to that black box. So then what we should do is to calculate VL on the left hand side and calculate VL on the right hand side, what it should be in order to make those two VL values equal to each other. That is what we're going to do. So let's write that VL value in this circuit. Since these two are connected in parallel, so the equivalent resistor value is R times RL over R plus RL. So if you consider this R equivalent resistance value multiplied with this current is going to be the current of this equivalent resistor as well. So if I multiply with this current, that means IS is going to be this VL value, isn't it? That is the VL on the left hand side circuit. What it is in the right hand circuit, right hand circuit, is these two resistors are connected in serial. So if I divide this Vs independent voltage source voltage to the equivalent resistance, then I'm going to find this current. This current also, this element current. Why is that? Because serial elements currents are equal. So Vs over R plus RL is that IL current. So this is IL current. If I multiply IL with RL, then this is going to be equal to VL. Now what we are saying now, this VL should be the same as this VL. How could that happen? So look at these two equations now, the right hand side here, left hand side here. So this RL over R plus RL, so that ratio is common in both of those. So what is left should be equal in order to have that VLs equal to each other. So use a different color here. So that means this multiplied with IS should be equal to this. So if I write it here, Vs should be RIS. This is what we have found. Conclusion, how we are going to interpret this conclusion is this. If you've got that circuit, that blue box in it, if you replace these elements with those two, that means independent current source in parallel with resistor R, replaced with an independent voltage source of which voltage is R times IS, multiplication of those those two. If you put an independent voltage source of that value in here in serial with the resistor, that box is equivalent to that box. Why is that? Because when you replace those two, the voltage of this resistance and this resistance do not change, and the current of this resistance RL and the current of this resistor RL in this circuit are going to be the same. That's why we call those two are equivalent to each other. Okay, the next step is this. This is a source transformation. Yes, it is good. What is the use of this? So in the analysis, we could use this. If you are using the source transformation from left to right, let me show it on here. So if I am replacing those two with those two, what happens is this. You see here there is two meshes, but in this circuit there is one mesh. Mesh is reduced by 1 after source transformation. So how I'm going to use that information? If this circuit is given to you and you made the decision that to solve this circuit, to analyze this circuit by using the mesh current method. So you're going to write KVL equations. While you are writing KVL equations, the number of equations is going to be less because you are writing the KVL equations for the meshes. One mesh is reduced, so KVL equations will be reduced by 1. That is the advantage of it. So we examined the situation here, the use of this transformation from left to right. What happens if this circuit is given to you and you transfer this circuit to this one? So make it in different color in this area, or make it blue. So if you are coming from this side, so that means Vs given to you, you're going to find out Is in terms of Vs. So from that equation, if you're going to this way, so Is is going to be Vs over R. So that Is value is going to be Vs over R. So this is given to you. So you are transferring this parameters to that independent current source, current value Vs over R, and put that resistor in parallel. They are equal to each other, isn't it? So in this case, what is going to be the use of this transformation? So you can check it now. The number of nodes here is just one here. That's the second one. That's the third one, including the reference. In here you've got 1 and 2. There are 2 nodes. So that means node number reduced by 1. Number of nodes reduced by 1. So assume that this circuit is given to you and you want to use the node voltage method. Then you're going to write Kirchhoff current law equations. Since one of the node is reduced, so you're going to use one less KCL equation you're going to write. So that is the use of F. So you are reducing the number of equations that you're going to solve. So that is useful, of course. That is another usage of it. One last thing maybe to mention, it is worth to mention, just before the last, let's say. So this current direction here is important. So in the calculation in here, we have chosen the direction of, or the reference of this independent current source upwards. So you've got to keep it like this. That is against the current reference of that independent voltage source. According to passive sign convention, this independent voltage source current reference is downwards. So if you are transferring to this one, your independent current source current reference should be upwards. Otherwise, there are some problems that you're going to face. That is one thing to be mentioned before closing. The other thing is, up to now, the number of the equivalency that we deal with, the final element type is the same as the original elements. When we said serially connected resistors, the equivalent resistor is another resistor. So all the elements, the equivalent element is also a resistor. But in here, the topology and the element types are changing. In here, there is an independent current source. In here, you've got an independent voltage source. And topology also changing. It is a parallel connection here, becomes a serial connection on the right hand side. That's why this equivalency a bit more complex than the serial and parallel connection equivalency that we have seen already. And that's the end of this video, and then stop recording.